Welcome back once again. We're going to take a look at factoring quadratics. We're going to do a little bit more with this as we take a look at some more factoring of quadratic type problems. The first, we have looked at the difference of two perfect squares. Well, now we're going to look at something called a perfect square trinomial. Perfect square trinomials are in this format. You'll see a number squared or a perfect square to start, a perfect square to begin with, and then you'll see this 2ab, which we'll get to here shortly. But if you were to FOIL a plus b times a plus b, you would end up with something that would look like a squared plus 2ab plus b squared. And then a squared minus 2ab plus b squared. If it's in that format, that would come from a minus b times a minus b. And I'll show you what I mean when we look at these next two problems. But before we do that, I want to tell you that you can still factor these exactly like we had talked about in the last section. In the last section, we looked at that and we'd create an x and we'd say, look for the number, the pair of numbers that multiplied together to give you 49 and added together to give you negative 14. So the numbers that multiply together to give me positive 49. Let's see, there's 1 and 49 and, well, 7 and 7. And right there, they multiply together, or they add together to give me positive 14. So that would tell me that I'd be looking for negative 7 and negative 7. So just like I did in the last section, I'd be able to factor it using this x, and I'd end up with x minus 7 times x minus 7. I could also write that, if you wanted to, as x minus 7, that quantity squared. Both of those things are exactly the same thing. But let's take a look at doing this a different way. So if I can recognize the shortcut, and that's the key here, again, recognizing the shortcut, what I would be able to see is I would be able to see a perfect square there and a perfect square on the other end. So we see a perfect square on both ends. And then if I look at the middle part, I should be able to see 2 times what I started with, x, times the number that's there at the end, 7. So I should be able to see that. And if I see that, if I do have this pattern, 2 times what I started with here, x, and what I ended with here, 7, right? Let me draw little arrows there. So you should see this value, and you should see this value, right? And if I see that there in the middle, then it's a really easy way to go from this original form to x minus 7 times x minus 7. Or, again, this is my a value. This is my b value, so it would be a minus b times a minus b. And again, the minus because that's a negative sign right there. Okay, that's hard to see. I would suggest that if you're having a hard time seeing this shortcut, that you continue doing it the old way by using the x. But if you do see the shortcut, it can save you some time and it can save you some work, because all of a sudden, a problem that I want to look for numbers that multiply together to give me 16, add together to give me 8. But if you recognize the shortcut, if you can see it, then that becomes very easy to just write it as x plus 4 times x plus 4, and I don't really have to do much work. But it's up to you to see that shortcut. If you don't, just go back to the old way, use the x. Now, sometimes though, especially when we have a number here in front, we haven't talked about how to factor that yet. So you want to look for that, and again, we can still use that shortcut. If you notice that shortcut, if you can see it, if you can write it, times 3 plus 3 squared. If you can write it out, right, you'll see the 4, that comes from right there. You'll see the 3, that comes from right there. And if this checks out, let's hear 2 times 4. 2 times 4 is 8. 8 times 3 is 24. That checks out. That's the way I would write that. And if I can write it that way, then my factored form would be 4x plus 3 times 4x plus 3. All right, let's take a look at some example problems. So go ahead, give these 6 problems a try. Check it out. Don't forget, you do need to look for a GCF first. We will go over the answers. We are going to use the shortcut for these. So try to use the shortcut and try to recognize the shortcut with these problems. Okay, and we'll go over the answers here momentarily. Okay, so as I mentioned, we're going to look at the shortcut and use the shortcut for these problems. So I'm going to try to show it to you here with each one of these. So in A, we have x squared minus 16x plus 64. Let's see here. That is x squared minus 2 times my x times 8 plus 8 squared. And if it works out, which it does, right, because 2 times x times 8 gives me negative 16x. And if I can do that, then my final answer is x minus 8 times x minus 8. Let's look at B. Again, I can see that shortcut. I see x squared. I see the 2 times x times 5 plus 5 squared. And I can see it, and that would give me x plus 5 times x plus 5. All right, let's keep. Okay, with letter C, you should see the 4x, that squared. Again, we just make sure we see that format. And oh, look here. Okay, well, remember, 1 is a perfect square because 1 squared still gives me 1. So my final answer for this problem would be 4x plus 1 times 4x plus 1. What about for D? Okay, well, if I look there, that's 6x squared. If I look down here, that's 7 squared. In the middle, I should see 2 times the A value times the B value. Let's check it out. 2 times 6 is 12. 12 times 7, calculator, yep, that's definitely 84. So I end up with 6x plus 7 times 6x plus 7. That would be my final answer there. Then we get to letter E, 50x squared plus 20x plus 2. Hey, I don't see a perfect square here. But don't forget the old rule. We got to pull out a GCF first. So if we have a GCF, we want to make sure we factor out the GCF first. So if I look at all three of these terms, what do they have in common? They have a 2 in common. And if I factor out the 2, I'm left with 25x squared plus 10x plus 1. And now I should be able to take a look for my perfect squares. So let's see here. Let's see if I have those in here. So 25, which would that be 5x squared? And then I have this 1 squared on the other end. So my middle should be 2 times 5x times 1. And that does, in fact, give me the 10x that I needed. So my final answer is 2 times 5x plus 1 times 5x plus 1. Again, if you wanted to, you could write that as 5x plus 1, that quantity squared, because it means exactly the same thing. Up to you with how you write that. What about for F? Well, if I'm looking at F and I'm looking to see what do those 3 terms have in common, they have a 4 in common. So I'd be able to factor out that 4. And I'd end up with 4 times the quantity of x squared minus 4x plus 4. And if I factor that down even further, again, using my rule, or again, going back to that x, which I could totally do with that problem, I'd get 4 times x minus 2 times x minus 2. So now we'll get into some factoring when a is not equal to 1. And when I'm talking about a, I'm talking about there being a number right here in front of x squared. We haven't seen this yet. So I'm going to show you 2 different ways that you can do these problems. And it's really up to you with which way you like the best. So the first method is going to be using that x. And we're going to start off with that actually with both methods. So we're still going to start off with that same x that we were using when we were factoring the other ones of these. Here's the difference. With us having a value for a, the top number is not just the last number. It's actually going to be a product of the last and the first number. So that a term and that c term, a times c. So in this problem, 6 times 4, which is 24. And then the bottom number is always going to be my value for b. So my middle number there, that 11. So what I'm looking for doesn't change with this x. I'm still looking for numbers that multiply together to give me 24 and add together to give me 11. And we can always write these out if I wanted to. So there's no problem with taking these numbers and writing them out until I find that pair of numbers that multiplies to give me 24 and adds together to give me 11. In this problem, it's 3 and 8. Now, from here, for my first method, I'm going to do something where I'm going to take that 8 and that 8 and that 3, and I'm going to do something that I call uncombining like terms. So I'm going to take that 6x squared, and I'm going to expand that 11x and turn it into plus 3x plus 8x. Okay, so I'm getting those numbers from right here. I'm getting that from the 3 and 8 that I came up with. And if you look at it, 3x plus 8x goes back up here and gives me my 11x. So I haven't really changed the problem. All I'm doing is kind of stretching out that middle term. I'm uncombining my like terms. And those are the numbers that I would have done if I'd uncombined my like terms. Now, after I've uncombined my like terms, what I can do is I can do something called factoring by grouping. Factoring by grouping is when I can take the first two terms, and I'm going to look for this GCF of those first two terms. So in this problem, 6x squared and 3x, what do they have in common? They have a 3x in common. So if I pull out that GCF of 3x, what do I have left over? I have 2x plus 1 left over. I'm going to repeat this process with the second two terms. So that 8x and that 4. And I'm going to say, what do they have in common? What's the GCF? The GCF of positive 8x and positive 4 is positive 4. And if I factor out the GCF, well, what am I left with? Well, let's see here. I'd be left with 2x plus 1. If you notice, the 2x plus 1 is the same in both of those. So this is kind of like me having two terms. This whole thing is one term, and this whole thing is a second term. And if I look at what they have in common, they have a 2x plus 1 in common. So what I can do is I can factor out the 2x plus 1. And I would have 2x plus 1 times the leftover stuff, which is the stuff that's written there in red. So the 3x plus 4. Now, if I were to go and check this, right, I'm going to check my answer that I end up with. 2x plus 1 times 3x plus 4. I can check my answer by foiling. So I'll do my firsts, and I'll get 6x squared. I do my outsides, and I'll have plus 8x. I'll do the insides, which has plus 3x, and I'll do the lasts, which is plus 4. And if I combine my like terms here in the middle, you will see that I end up back with my original equation. So I checked it, I'm right, that is my final answer. Let me show you the second method. For the second method, I still do my x exactly like I did before. I still do that x, I still look for the numbers that multiply together to give me 24, add together to give me 11, I still do that. But here's the other thing. Here's the other part that I do. After I create my x, I'm going to create a box. And in that box, I'm going to put my first term in the upper left corner. I'm going to put my last term in the lower right corner. And I'm going to take that 3 and that 8, and I'm going to put them in the diagonal of that. I call this method the X box method. See, there's an X, there's a box, X box, get it? Okay, great. So what you're going to do now is after you have it written in this form, you're going to look in each row and in each column and find out what is the GCF. So I'm going to look here at this top row, the 6x squared and the 8x, and I'm going to say, what do they have in common? Well, if I look at those, I'll see that they have a 2 and an x in common. I'm going to do the same thing here with this bottom row, the 3x and the 4. What do they have in common? I don't see anything, so I'm going to put in a plus 1. I'm going to use a placeholder. Now I'll go for the first column, the 6x squared and the 3x. What do they have in common? They have a 3x in common. What about the 8x and the 4? They have a positive 4 in common. And right now, with in each row and each column, I can now take that, and I can take that 2x and that plus 1. That's going to be one factor, and the other factor is going to be 3x plus 4. And if you notice, that's the exact same answer we got on the last slide. So it's really up to you. Which method do you like better? Do you like the uncombining like terms and then factoring by grouping method? Or do you like the Xbox method better? It's really up to you with what choice you make, with which way you like to do the problem the best. When you get really good at these, you may even want to just guess and check to try to come up with your answer on your own. But let's do 5x squared minus 17x plus 12. Let's do one more together. I will again show you the x. We always start with the x. So I'm looking here, and I'm going to take a times c. So I'm looking for the pair of numbers that multiplies together to give me 60. But adds together to give me 17. So multiplies together to give me 60, but adds together to give me negative 17. I'd make my list, and I'd come up with the answers of negative 12 and negative 5. Okay, first, let's do x box first. So if that is my x, my box looks like this. My box, I'd write my box, and I'd put the first term in the upper left corner, my last term in the lower right. I take my two numbers, that negative 12x and that negative 5x, and I put them in the diagonals. I would then look for the GCF in each row and each column. So the top row, what's the GCF? 5x squared and negative 5x? It would be 5x. What about the bottom row? I would actually pull out a negative 12 here. I'm pulling out the negative because this sign right here is a negative, and if it leads with a negative, I want to make sure the negative is there as well. Okay, what about the first row? What do they have in common? They have an x squared in common. What about the second row? Second column. What do they have in common? Just a -1. And again, hold on, I have to fix that. I messed up. That should be just an x right there. I don't know if I said x squared or not. Then what do I have? I have my answer. My answer is what I see here. I see the 5x minus 12, and I see the x minus 1. That will be my answer for this particular problem. Now, if you wanted to go the uncombining like terms route, you'd still have that same x over here. You'd have this same x, but what you would do is you'd take that 5x squared, you'd take that plus 12 at the end, you'd split the middle. So negative 12x minus 5x, that gives you that negative 17x you were looking for. And now I'm going to look at these first two terms and I'm going to pull out the GCF. Well, that's just x here. And what do I have left? I'd have the 5x minus 12 left over. What about the second two terms? What do they have in common? I don't see anything, but I'm going to make a -1. I'm going to have a -1 here for this. Because when I do that, then I will see that my two parentheses will match. If I only factor out a +1, they're not going to match, and that would be a bad thing. Then I see that they have that in common, so I'll write the 5x minus 12. And the leftover stuff goes in the other parenthesis, the x and the -1. And you'll see that I end up with the same answer no matter which method I used. So now, why don't you pause the video? I know it's going to take you a little longer to do these 6 problems. They are a little more complicated. So please make sure that you pause the video, try these problems out. I will tell you, factoring out a GCF using either of these methods is extremely important. So please be careful when you have to factor out a GCF. Make sure you do that first. Okay, pause the video now, give these problems a try, and I'll reveal the solutions momentarily. Let's take a look at problem A, 3x squared plus 2x minus 21. So when I do the x, I'm looking for the pair of numbers that multiplies together to give me -63, adds together to give me 2. That would be -7 and 9. If you didn't get that, try that now. I'm going to use the uncombining like terms with this particular problem, and I'm going to expand out that middle, and then I'm going to factor by grouping, and I'm going to look what do they have in common. And what about the second two? What do they have in common? If at any point you get two parentheses here that don't match, you've probably done something wrong and you should try again. There's my answer, 3x minus 7 times x plus 3. What about the second problem? B, 4x squared plus 8x plus 3. So I would look for the numbers that multiply together to give me 12, add together to give me 8. What would they be? That would be 6 and 2. I'm going to go ahead and use the Xbox method for this pair, or for this problem. So you can see two different methods side by side. Remember, no matter what method you picked, you would still get the exact same answer. So if I'm looking for GCFs now, looking for a GCF here, I'd look up and down. What's the GCF? It would be 2x. What about for that? Just 1. And my final answer would be 2x plus 1 times 2x plus 3. Let's go on to some others. What about C? Again, I'm looking for a GCF. I don't see one. Don't forget to do that first. For this pair of problems, I'm looking for the pair of numbers that multiplies together to give me -120, adds together to give me -7. Boy, I'm glad I could write out my list here if I needed to. I get -15 and +8. So when I uncombine my like terms here, I'd have 6x squared minus 15x plus 8 minus 20. I'll look for a GCF. So what do those first two terms have in common? They have a 3x in common. And that would leave me with a 2x minus 5 left over. Whoops, that's a 5. Let's make that look like a 5. What about the second two? I dropped an x there, my apologies. What about the next two? They'd have a 4 in common. So that's here. I'd be left with a 2x minus 5 left over. And right there's my answer. 2x minus 5 times the leftover stuff, 3x plus 4. Let's go to problem D. Let's see here. What am I looking for here? A times C. So the pair of numbers that multiplies together to give me 12, adds together to give me 7. What would they be? 3 and 4. Let's do the X box. So let's see here. There's the X. Here's the box. So I'll put my first term in the upper left, my last term in the lower right, +1. and then I'd put my 3x and my 4x in the diagonals. No, it doesn't matter which one you put where, as long as those numbers are in the diagonals. I'll look for the GCF there, and I'll look for the GCF here, and here. My final answer, 3x plus 1 times 4x plus 1. Last two problems, and these are the ones where you have to remember to factor out the GCF first. So if I look at all three of these terms, I'll see that I can factor out a 5. And when I do, I'm left with 3x squared plus 13x plus 4. Now, you got to pull out the GCF first. If you do not do this, Xbox and uncombining like terms, it starts to break down, especially Xbox. But once you do that, we kind of ignore the 5, and we just look at this inside the parentheses, what's inside the parentheses, and we factor that the way we've been doing with all those other problems. So we'll see 12 and 1. When we factor that, when we get that down, when we factor out that trinomial, you should end up with 3x plus 1 times x plus 4. Now, what about that 5? Don't forget to slam that 5 at the beginning. Okay, you need to make sure that's there. But that other polynomial on the inside factors down to give you 3x plus 1 times x plus 4. What about f? What does f? What's the GCF? There is a GCF here as well that we have to make sure we get. That GCF is 2. After I factor out the 2, let's see what I'm left over with. 8x squared minus 10x plus 3. Then, if I go through and I factor out this trinomial in here, again, looking for the pair of numbers that multiplies together to give me 24, adds together to give me negative 10, I go through the X box, or I use my uncombining like terms method, whichever I prefer. I'll get that 8x squared minus 10x plus 3 to factor down to get 4x minus 3 times 2x minus 1. Make sure you get that GCF out first. That's going to be the difference between you getting these problems correct and not. Folks, that's the more complicated of the two methods, or the more complicated of the two problem types that we have here with factoring quadratics. So we're going to practice this concept an awful lot. So hopefully you'll get really good at it. Okay, if you have any questions, please let me know. Good luck.